Hello again, class. This is Mr. Liao again, and we're finally on to chapter 12, the last chapter. And this is section 12.1, angles of triangles. In this section, we're going to classify triangles by sides and angles, and then we are going to find interior and exterior angle measures of triangles. So classifying triangles is pretty simple. Remember, a triangle is a polygon with three sides. You guys know what a triangle is. You can classify them by sides, and then you can also classify them by angles. So classifying triangles by sides, it's all about how many sides are congruent with other sides. First, a scalene triangle has no congruent sides. An isosceles triangle has at least two congruent sides, and an equilateral triangle has three congruent sides. Now notice that this means all equilateral triangles are also isosceles because isosceles triangles need only to have at least two congruent sides and equilateral triangles qualify. Now let's classify triangles by angles. Now an acute triangle has three acute angles. A right triangle has one right angle. An obtuse triangle has one obtuse angle. An equiangular triangle is a type of acute triangle with three congruent angles. So notice a right triangle can only have one right angle. A triangle can't have two right angles because the angles of a triangle add up to 180. So one angle is 90. A second angle can also be 90. Same with an obtuse triangle. Because if one angle is more than 90 degrees, there can't be another angle that's more than 90. So equiangular triangles are also equilateral. Equiangular triangles are also acute triangles. Equilateral meaning equal sides. 1a, classify the triangular shape of the support beams in the diagram by its sides and angles. So notice the hash marks will tell you how many congruent sides there are. So you can see there are two congruent sides based on these markings. So this triangle is an isosceles triangle. Now in terms of angles, you can just look at the diagram and you can see that all three angles appear to be acute. So this is an acute isosceles triangle. 1b, now notice this triangle has no congruent sides. There's no markings indicating they're congruent. This triangle also has exactly one right angle. Notice there's a box there that indicates a right angle. So this is a scalene right triangle. It's scalene because no sides are congruent. It's a right triangle because the triangle has one right angle. 2a, classify triangle OPQ by its size and determine whether it's a right triangle. So what you're going to have to do is to figure out how long all three sides are. Now you can tell it's not an obtuse triangle. So what we're going to have to do is use the distance formula to find the length of each side and see if any of them are congruent. Now you can look at the diagram and you really only have to look at the two longer sides to see if they're congruent. So I'll consider OP, but OP you generally won't have to check because this side is clearly shorter than the other two sides. So you really want to see if PQ and OQ are congruent. And that's what you'll be looking at. But I'll do the distance formula for all three. So OP, if you drew a right triangle, it's 1 squared plus 2 squared. So 2 squared there, 1 squared there. That's the square root of 5. So that's about 2.2. OQ, so you have this side here and this side here. So this is 6. This is 3. So it's the square root of 6 squared plus 3 squared. That's the square root of 45, which is about 6.7. Finally, we have PQ. So we draw another right triangle. There's 1, there's 7. So you can see that's not going to be the same as OQ. This is the square root of 50, which is about 7.1, which tells you that, whoops, no congruent sides. So triangle OPQ is a scalene triangle. So now we've taken care of the sides. You just basically got to see if there are any sides congruent. And if there's a side that's clearly not congruent like OP, you don't have to worry about actually checking it. Now we're checking for right angles. You want to see if any slopes are perpendicular. So you can look at the angles to see, well, which is the most likely candidate for a right angle? It looks like angle O is the most likely candidate. So we'll look at the slopes of the three sides. OP has a slope of -2 over 1 or -2. Okay, it's going down 2, right 1. Next we have OQ. OQ goes up 3, right 6, and that's a slope of 1/2. Now you can already see, you can stop right now because OP and OQ slopes are negative reciprocals. Negative 2 times 1/2 multiplied together is negative 1. If you take 1/2, flip the fraction, make it negative, you get negative 2. Now just to complete it, PQ has a slope of 1/7. So since you have negative reciprocals, angle O is a right angle, and thus triangle OPQ is a scalene right triangle. So to classify triangle by sides, and if it's a right triangle, you'll have to find how long each side is to use the distance formula, or really the sides that might be congruent. And then if it asks you for a right angle, check the slopes of the line, see if any of the two sides are negative reciprocal slopes. You can try 2B if you want, or you can just watch me do it. ABC. So let's start with the sides. AC is clearly shorter than the other two sides. I'm just including it here to be complete. Let's look at AB. AB is the square root of 7 squared plus 2 squared. So if you take a look at this, that one's 7 across, that's 2 down. So the square root of that is 7.3. Finally, we have side BC. BC is the square root of 6 squared, so it's 6 across there, plus 2 squared. That comes out to the square root of 40, which is about 6.3. Again, we have a scalene triangle, no congruent sides. So now let's take a look at the slopes of the three sides. Really the candidate that's most likely to be a right angle is C. So let's just take a look at all three sides anyway. AB, to go from A to B, you're going to go down 2 right 7 for a slope of negative 2/7. For AC, to go from point A to point C, you're going to go down 4 right 1. That's a slope of negative 4. For BC, you're going to go up 2 right 6 for a slope of 2/6 or 1/3. Now notice none of these slopes are negative reciprocals of each other. So this is not going to be right triangle because there are no right angles. So this is a scalene acute triangle. Next, we're going to move on to interior and exterior angles. Interior means inside, exteriors are outside. So when sides of the polygon are extended, other angles are formed. So notice it's a triangle, and basically they extend the sides such that each side ends up being a line. So the original angles, the ones in red, are the interior angles. They are inside the triangle. So the triangle has 3 interior angles. The angles that form linear pairs with the interior angles are the exterior angles. So notice it's going to be the linear pair. So there and there, those two are linear pairs of each other. If you put them together, they're basically supplementary because they're next to each other. And you can do the same with the other two angles of the triangle. So B, inside B, and outside B, those are exterior angles. Now notice you could have chosen B to be outside on the other side because it's also going to be the same measure because they're vertical angles. So interior angles inside, exterior angles outside. So the triangle angle sum theorem is a rule you probably are familiar with. If you add up the measures of the 3 interior angles of a triangle, they will always add up to 180 degrees. Always, always, always. 180 degrees. Now the exterior angle theorem says that the measure of an exterior angle is equal to the sum of the measures of the 2 non-adjacent interior angles. So here's angle 1. Angle 1 is an exterior angle. It's going to equal the measures of A and B added together. So the sum of the 2 non-adjacent interior angles. Now you might be wondering, why is that? Well, that's because angle C is supplementary to angle 1. And since A plus B plus C have to equal 180, that means A plus B has to equal angle 1 because of the transitive property of equality. Example 3a, find the measure of angle JKM. So the exterior angles theorem states that an exterior angle, in this case 2x minus 5, is equal to the sum of the 2 non-adjacent interior angles, so 70 plus x. So your equation is 2x minus 5 equals x plus 70. Subtract x from both sides, add 5, and you see that x is 75. So the exterior angle theorem says the exterior angle is equal to the measures of the other 2 interior angles added together. Now measure JKM is what we want to figure out. So JKM is 2 times x, which is 75 minus 5. So the measure of the exterior angle is 145 degrees. 3b, find the measure of angle PQS. So again, we're going to use the exterior angles theorem. So the exterior angle 3x plus 25 is equal to the sum of the 2 non-adjacent interior angles, the sum of the 2 other interior angles. So 3x plus 25 equals 2x plus 65. Subtract 2x from both sides, subtract 25 from both sides, and you're left with x is equal to 40. You're now going to plug in 40 into the expression for angle PQS. So 3 times 40 plus 25 means that angle PQS is 145 degrees. A corollary to a theorem is a statement that can be proved easily using the theorem. So all you have to know about a corollary, it's kind of like a theorem. It's a rule that's a rule of geometry. Okay? You don't have to worry about what the difference is between a corollary and a theorem. Just think of it as a rule based on a theorem. So we have something called the corollary to the triangle angle sum theorem. Recall that the triangle angle sum theorem means that all three angles inside have to add up to 180. Here the corollary says that the acute angles of a right triangle are complementary. So here angle C is a right angle. That means angles A plus B have to equal 90. That's the corollary. So example 4, find the measure of each acute angle. So you notice you have a right triangle and you have two acute angles inside. The corollary states that those two angles added together have to be complementary. In other words, they add up to 90 degrees. Makes sense? If those two add up to 90 plus the third angle, which is a right angle, those three angles together add up to 180. So 2x plus x minus 6 equals 90. Combine like terms, you get 3x minus 6 equals 90. Add 6 to both sides, you get 3x equals 96. Divide by 3, and you get x equals 32. You will now plug in 32 for x for both of the angles. 2 times 32 is 64. X minus 6, 32 minus 6 is 26. So the two acute angles are 64 and 26 degrees. So that's it for section 12.1. Keep up with chapter 12. It's going to get a little more challenging with proofs, but y'all can do it. Y'all stick with it. If you have any questions, you can email me or contact me using many of the ways you can reach me.